When people think about the RMS Titanic, they usually imagine massive engines, giant propellers, or luxurious interiors. Please subscribe. But one of the most important parts of the ship was something much smaller: rivets. These metal fasteners were used throughout Titanic's structure, connecting steel plates and holding the enormous vessel together piece by piece. At the beginning of the 20th century, riveting was one of the primary methods used in large-scale shipbuilding. Welding technology had not yet become the standard for constructing massive steel structures, so ships like Titanic relied on millions of rivets to create strong mechanical connections between metal components. The basic idea behind a rivet was simple. A rivet was a short metal pin with a head on one end. Workers inserted the heated rivet through aligned holes in overlapping steel plates and structural beams. On same place, the opposite end of the rivet was hammered and shaped into a second head, locking the pieces tightly together. Although the concept sounds straightforward, applying it to a ship as large as Titanic required extraordinary organization and labor. Thousands of steel plates formed the hull and internal framework, and every connection depended on rows of rivets placed with precision. The strength of the ship relied not just on steel itself, but on how effectively those pieces were joined together. The riveting process involved teams of workers operating in coordination. Rivets were heated in furnaces until they became extremely hot and glowing. One worker removed the rivet using tools and quickly passed it to another, sometimes by tossing it through the air. The rivet then had to be inserted into the steel plates before it cooled. Other workers hammered it into shape using heavy tools or pneumatic equipment. Timing was critical because the rivet expanded while hot and tightened as it cooled. This created a strong clamping force that helped secure the steel plates together. The cooling process effectively locked the structure into place. Different sections of Titanic used different types and sizes of rivets, depending on the stresses involved. Areas exposed to higher forces required stronger connections and careful placement. Engineers considered factors such as water pressure, vibration, structural loads, and movement through the ocean when designing the rivet patterns. The rivets also played a role in distributing stress across the hull. Instead of concentrating force in one area, rows of rivets spread loads throughout the structure. This helped the ship maintain strength, while still allowing slight flexibility as it moved through waves. Another challenge was scale. Titanic was one of the largest ships ever built at the time, meaning the number of rivets required was enormous. Workers repeated the same demanding process again and again across the shipyard, connecting plate after plate as the structure slowly took shape. From a construction perspective, riveting was both industrial and intensely manual. Large machines assisted in some tasks, but much of the work still depended on human coordination, physical effort, and experience. The building of Titanic reflected a transition period between traditional craftsmanship and modern industrial production. The sound of riveting became one of the defining characteristics of shipyards during that era. The constant hammering of metal echoed through construction areas as workers assembled massive steel structures piece by piece. Looking back, Titanic's rivet system reveals how engineering depends on details. While engines and propellers attracted attention, the ship could only function because countless smaller components held everything together. Even the largest structures rely on the strength of their connections. It also highlights the importance of labor behind industrial achievements. Rivets did not place themselves. Thousands of workers contributed to the construction process, shaping the ship through repetitive and physically demanding work. More than a century later, Titanic's rivets continue to be studied as part of maritime history and engineering analysis. They represent the construction methods, materials, and industrial practices of the early 20th century. In the end, the rivets of the RMS Titanic were more than small pieces of metal. They were the links between every section of the ship, the fasteners that transformed separate plates into one massive structure, the hidden connections beneath Titanic's steel exterior, and one by one, heated and hammered into place. Those rivets helped create one of the most famous ships in history, through precision, labor, and the industrial power of its era.